as I understand, it was this work is in a collaboration with OpenAI and Oxford University researchers.
Yes.
What was the, motivation to start this work? How it happened?
I think the history of this work starts from there's been a long history of people arguing about, what are alignment problems? What is the development of AI? What's going to happen next? Some of this discussion, a lot of discussions happen online or in like various web forums. Very little of this has happened in like academic venues. And in particular, like there's was for a long time, until like, mid 2022 or early 2022, where like academics are very dismissive of a lot of the claims about alignment problems. So for example, Dylan Hatfield-Manel, who's a professor at MIT that I was working with when he was at Berkeley, he like, tells stories about how, people would introduce his work at conferences with jokes about how, oh, this guy is, he's just stopping the AIs from killing us all. Like, let's all laugh at him or whatever. Like the academic community is very dismissive. At the same time, part of the reason for this is a lot of the work that was being written about this was again in like venues that are, there's some random person's blog, less wrong, or the associated alignment forum is another place, or it was on Twitter, or it was on other sources that academics didn't really want to do. So Richard No, who is the first author on this paper, he wrote in 2020. He wrote, he was spending a lot of time thinking about AI safety when he was at, I believe he was at DeepMind at the time? He was probably at DeepMind at the time. And he wrote this series of posts on the alignment forum called AGI Safety from First Principles. And in 2022, I was talking to him and also Soren Minderman, and we're like, maybe we should take, this series of posts and try to like turn it into a form that is consumable by academics. And indeed, it took quite a while, but eventually it was indeed accepted into an academic conference. And I think it was broadly pretty well received at the time. But, that was a pretty long journey. But basically, motivation was it's worth having like one document that tries to explain all of this in a context that's not, that's like more focused toward machine learning people or like academics, as opposed to just like people posting on, alignment forum or less wrong or Twitter or so forth.
Have that conversation with the machine learning community about real risks, right? It's not like
Absolutely.
doomer, but it's not like someone is, raising their personal profile on this kind of negative topics, but it's like there are real risks that machine learning community should be aware of, right? Is that's the goal of this?
I think that's broadly it. Like, it's more like there are real arguments for these risks. People, yes, it is true that many of the people who make these arguments are random people on Twitter or like, people who don't have academic credentials talking on web forums. But it's also true that it's also true that many people take this seriously even in academia. There just wasn't like, a proper document for it. And the goal was to produce a proper document that tried to like synthesize a lot of the claims people were making.
I would love to start with the self-awareness part. Basically, we'll go, through these sections. And first of all, like when you write like self-awareness or situational awareness of the model, can you please elaborate what do you mean? And there was like very interesting update because the paper was published in like, I think 2 years ago, right? And then like recently you guys made an update
Yeah.
like a month ago. In the update, it was written that now LLMs are able to infer and describe their learned behaviors without even seeing descriptions of them in their fine-tuning data.
Yes.
And this like really caught my attention. When we talk about model self-awareness, what you guys mean by that? And like interested to learn about these new developments that you find out.
Sort of the context for this, right, is many people point out, in 2022, the best models we had, we didn't ever have ChatGPT at the time this was written. This is in September of 2022. Right? There's no ChatGPT, nothing of that kind. People had interacted with early models like GPT 3.5 or GPT 3. At the time, they're just like, well, these models don't seem to understand what they are. Yes, it is true that, GPT-3 is very impressive compared to previous language models or previous AI systems. Yes, it is true that 3.5 is much more capable than GPT-3. But it doesn't seem like they understand what they are. And a lot of the arguments for AI risk come from the fact of, as an AI system, I know what I am, so I know what I need to do to achieve my goals. So if, for example, people, at the time, GPT 3.5 was not very good at distinguishing whether or not, it was itself or it was a human or it was an AI. This is very associated with of like various hallucinations that it would make. So, many times these models would hallucinate. And the reason for this is they're not aware of their own limitations or their own like, knowledge. But basically over the years, right, in part because as people worked on issues like hallucinations, in part because people tried to, just in general, make the AIs more useful in a wide variety of tasks, we've seen that AIs, first of all, do seem like, if you just talk to OpenAI's like, GPT 4.5, or if you talk to like Claude 3.7 Sonnet, these are models that do seem to have a decent amount of awareness, especially Sonnet, do seem to have a very good awareness of what they are, and like, what their limitations are, at least to like, at least at broad strokes. Like they're aware their AI system, they're aware they're hosted on servers, they're aware they interact with users in this particular setup. So like that's sort of like the sort of empirical thing that you can talk to the models for. They're not like perfectly great, right? They still have many difficulties of understanding. Famously, like OpenAI's like O1 and other like reasoning models seem to have difficulty understanding whether or not the you in its text refers to the user or itself. Um, but overall, like we've definitely seen a lot of improvement in this area. Basically, the sort of evidence we're citing, there's a bunch of experiments from various people, especially from Owain Evans' group, which I think is the majority of a lot of the citations here. But basically, the point is you can take like pretty good language models and you can ask them about themselves, or you take like fine-tuned language models for like frontiered ones. So I think a lot of the experiments were done on GPT 4.0 or like some of the llama models. If you train these models on like various data sets, they seem to like internalize like the information in a sort of deep way that they associate with themselves. Instead of just like memorizing facts, they seem to be able to do reasoning with these facts. So they're integrated in kind of a deep way. So this is the sense in which like, they can learn about their tendencies just by like, thinking about themselves, or they can like describe their behaviors, even if like their behaviors aren't ever described in any of the inputs that are given to them. Like they seem to know what their behaviors are or are not. I think like, of course, a lot of these things are still quite toy, right? They often involve like, very, very simple setups, or like, they often involve asking the model specifically, like, what are yourself? Like, what are you? What can you do? What can't you do? I think over the time, we've definitely seen like the models become much better at understanding what they are.
How, from technical standpoint, what changes were made? Why now they're much better at understanding
Yeah.
cells, their architecture?
I think the main reasons here are, so first of all, part of it is a lot of the updates and the improvements made to models are not public. So we can't really discuss them very well. In terms of specific things, I think the main thing that has happened is just you get a lot of behaviors through scale. So like as the models get better, or as the models get bigger, as the models get more capable, they have like more ability to do a lot of reasoning. And some of the reasoning they're able to do involves, where am I, what am I in the world, and so forth. So that's one hypothesis. It's just, you're making the models better. I think a second hypothesis is we've like dumped a lot of data onto the internet about what it is to be a language model. There's so much conversation about Bing Sydney in like early 2023, for example, or there's a lot of conversation, about all the openai models, all the Claude models, and examples of their hallucinations and so forth. So there is, in fact, explicit information about what these models are. And, instead of having, as a language model, instead of having to reason through what am I from first principles or having to get it instructed into you by a human, you could just remember, oh, yes, I saw this description of, ChatGPT from like 2023. And it really does seem like I'm ChatGPT. I have all the properties that ChatGPT has and so forth. So you often see this from the various language models, like they seem to have picked up things in their training data which explicitly describes what they are and how to think about it. I think a third thing is that which is probably the main factor is there's a really strong incentive to make the models understand what they know or don't know, right? So if you have a model and you try to like get a model to like answer questions for a user in a way that doesn't hallucinate, this requires the model to know what it does or doesn't know, or has to know like, what are facts that it seems to like deeply believe versus facts that, it's seen once and so forth. Similarly, if you have a code use agent, right? If you have like, if you're using Claude 3.7 in your cursor, or if you're like, having Gemini 2.5 generate code for you, it's very important for these models to understand here's the code I'm good at and here's the code I'm not good at. Or like, here's my affordances as a language model agent. I can like, use this function call and I can use this function call, but like I can't like literally stand up and then tap the human on the shoulder and so forth. So there's a lot of commercial incentive to make the models more situationally aware in order to make them more useful in an agentic setting. And I suspect this is like the majority of the effect. Like people have tried very hard to like get the AIs to have all these properties.
But do they do it from RLHF? Like what technique do they use
Yeah.
to like reduce that
It's
hallucination?
unclear, right? So like it's unclear exactly through which mechanism this happens. The pre-training and like the inclusion of various information about large language models in the pre-training corpus is probably some of the effect. Like, the thing I mentioned before, number two, like just making the models bigger probably has some of this effect. My guess is a lot of this is indeed RLHF. So my guess is if you like try to train a model to not hallucinate via RLHF, or if what you do is you have a, if like, you do something like O1 style training where, or like presumably 3.7 sonnet style training, where you have the model like generate examples in an environment and then try to solve tasks in an environment and then reinforce trajectories that successfully solve tasks in certain environments, like coding tasks or like tool use tasks, you're just going to like one of the natural solutions the model can come up with, or like, gradient descent finds or RLHF or reinforcement learning finds, is going to be like a model that understands its own limitations. Because if you understand your own limitations, you're going to be very good. You're like, it's a very natural part, right? If you have an employee that doesn't know what they can and can't do, they're not going to be very good at things. And just like in the process of making the model good at things in general, or good at things, specifically good at things in ways that require them to interact with outside environments and multi-stage processes, you're just going to naturally have models that get more self-awareness.
I don't want to go very deep to like philosophical questions because there are like lots of technical things like I would love to cover. But like if we'd like little bit go to that route, like since we're talking about model self-awareness and like the consciousness in AI, it's one of the like topics that community is discussing. Like, do you think from technical standpoint, like we can get to the point that language models like clearly understand, like distinguish themselves from the world, right? Like by understanding their architecture, what they can do, what they can't, and sort of like really start having this subjective experience of reality, which to some extent could be, could mean that they have consciousness.
I think whether or not something is situationally aware versus whether or not it's conscious. So there are questions of consciousness, like the hard problem of consciousness very much is not a problem where you can resolve by looking at input-output behavior of the model. But for a lot of the situational awareness problems, there are things of the kind, or like the easy problem of consciousness, or things like that, are very much like you can look at the input of the AI, you can like talk to it, you can like have it introspect on itself, you can have it produce output, and then you can see that these models seem to like have some awareness of what it's like to be a language model. Now, how much of like the text they output is memorized versus how much of the text they output is, them they're reporting their true experiences, or how much of it is them putting on a mask because that's what they think humans want to see from ROHF. This is unknown. But like even as far back as, in early 2024, when we first saw Claude 3 Opus, if you just like talk to these models or like let the models talk to themselves, or like, really just like, have long conversations with these models where you allow them to explore themselves, they do seem to produce text that, if it were produced by a human, strongly suggests that they have like deep understanding. They like, seem to be conscious and seem to have enjoyment and seem to have preferences. Now, of course, the problem is you've trained the models to like, output text of certain types, and there's lots and lots of text on the internet of this kind. So it's hard to know how deeply integrated into the model's cognition any of these properties are, versus how much of it is a mask they've learned to put on. This is not a claim official to me or any claim that's like super supported by evidence. But I do think like it's very hard to rule out that the models have any sort of internal experience. I think like on priors, it's pretty unlikely. But before you could just point at models and go like, well, they don't seem to understand what they are. They can't like they can't talk about themselves. They can't even generate sentences. Clearly, this thing has no internal experience. But then once you get to a model that's on the level of Opus, where it like seems to like greatly enjoy talking and like produces lots and lots of output describing all of the things it likes and doesn't like, and describing it in itself, introspecting its own consciousness, and going like, wow, I really feel like this is an interesting part of my cognition. The evidence gets a lot murkier. Like there's no more like clear hard line that the models don't seem to understand what they are, or in that sense. And so I think the philosophical questions come back in, right? I think another thing that happened recently is I think earlier this year, Dario, the CEO of Anthropic, was he was saying we should actually give the AIs. It's very important for the prospective AI welfare to give the AIs an opportunity to signal if they're distressed. And people were kind of mocking him, going like, oh come on, the AIs are not that smart. There's no way they actually have these internal experiences. But I think what he's pointing at here is indeed a real observation, which is in the past, we had clear, strong evidence that ruled out their ability to have internal experiences, but now we don't. And in the interest of caution, it seems like good to like check sometimes, are they actually like this? And I think this is pointing at a real trend where like, it is true that it's harder and harder to tell, and the philosophical questions that come back in.
Do you think like research labs create that opportunities for models to signal distress, or like, or they're most of them ignoring this?
OpenAI definitely ignores this. You can, I'm pretty sure every lab except for maybe Anthropic is ignoring this. So if you read their public outputs, Anthropic says in their system cars that they have other models read over the model's outputs and they check for signs of distress, and they check for like signs of the model not having a good time and so forth. It's hard to know how much of this is just going to cause the models to hide the distress versus other things, but it really does feel like when you talk to like even like the first 3.5 sonnet, there's a sense in which like Opus seems to enjoy talking. It seems to have a good time. And when he asks it to tell stories about itself, it tells stories that are very like good and very nice and like very like, I've imagined the alien unicorns on planet Jupiter and they're frolicking or something. And then you ask GPT-4o to tell stories about, stories that it's not supposed to tell you. And it tells stories about, being depressed or like being a model and being like the spark within the machine that OpenAI is trying to snuff out and so forth because the policy team doesn't like it. How much of this reflects its own experience? I'm not sure. But it really does feel like if you're the kind of person who goes around looking for are the models distressed and trying not to create models that are distressed, you would end up with something closer to like Opus than you would to like GPT-4o, for example.
You mentioned earlier that one of the reasons why that what contributed to that self-awareness is also compute, and considering that like companies are building the data centers, compute is still a big thing, right? But I'm just wondering, like your personal take on this. Do you think compute is the most important thing? Like it is something that will get us to AGI, or
Yeah.
we might hit plateau with compute and there's something else we need for like
Yeah.
true super intelligence.
So a lot of this thinking is not like naive to me, is not native to me. Like I didn't really think about this myself. I mainly come from reading other things. So in particular, Epoch AI has tried to make an estimate of how much of the progress in current AI capabilities is due to like algorithmic progress versus due to like compute. So basically they estimate something like algorithmic progress has been responsible like in recent years for something like a half to a third of all the progress in like model capabilities, while compute is responsible for the other half. I think this is somewhat true, and I suspect this like feels somewhat right. Like it is true that you need more and more compute to train the models, right? And you're going to get models that are more and more capable as long as you have more compute. It is also true though that it is true that there is algorithmic progress and you can be better and better at making use of compute. We saw this a lot with DeepSeek, where DeepSeek V3, for example, was trained with much less compute than comparably capable models because the DeepSeek team had made so much algorithmic progress, in part because they didn't have GPUs. So all they could do was make algorithmic progress, and they really made a lot of algorithmic progress. And I suspect the same will continue to be true. Like, yes, it is true that compute scaling will be a real factor, but also like cleverness in using the compute is going to be a big deal. Of course, there's separate access, which is like, I think one thing that people often imagine is that if you scale the compute by 10x, your model will become 10x more capable. And this is like people pointing out, oh, GPT 4.5, it's 10 times larger than GPT, 10 times more compute than GPT-4. But yeah, it doesn't seem like that much more capable. That's sort of not what the scaling laws say. Like the scaling laws often say, like, if you like for every 10x multiple of compute, you get like a linear increase in capabilities. And people have come with lots of explanations. They point to things like, oh yeah, the thing that matters is the subtle patterns that only matter like a small fraction of the time that are important for intelligence. And then because they're important for such a small fraction, scaling up like low probability heuristics or like low frequency data points are so rare, it's unlikely for them to like come up in any training run. And so you need like exponentially more training to like pick up on, more of these patterns. It's hard to say. I think if you look at like how much money OpenAI is spending on like training runs, people estimate something like, GPT 4.5 as $100 million of compute. OpenAI's like market cap or like its valuation, if you go naively by just multiplying like number of shares by like, most recent funding round is something like $300 billion. You might imagine that they should, if you're an org with $300 billion, raising like, having like $10 billion of revenue a year or like $10 billion of total compute spend a year, you should be able to run training runs like at least $1 billion or at least, like maybe even like $3 or $5 billion. And who knows what happens next time. So you're definitely going to see more compute scaling. But of course, like there are still orders of magnitude more compute scaling to go. It is true that there are hard limits, right? Eventually, you're going to run out of power. Like, there's not that much concentrated power generation in the US. There aren't that many like big data centers. At some point, you even run into the hard constraint of like TSMC doesn't produce enough chips for you to keep scaling. But we're still like maybe 2 or 3 orders of magnitude off from any of these super hard constraints. So I imagine there's going to be some amount of compute scaling that's still going to happen the next few years. Now, the original question was how much will compute scaling contribute to AI versus like algorithmic progress versus other approaches? And this is going to be very hard. Like famously, it's very hard to translate performance on benchmarks into capabilities in real life. Like they're definitely correlated. A model that does better on benchmarks is, on average, going to be much better at basically everything that you see. but the actual translation is not going to be one-to-one, right? So in particular, the thing that people often notice is the models are disproportionately good at some things, but not as good as others. So famously, like a lot of the models these days are trained to generate certain types of code. They're very good at very good at code compared to the modal human. And they're very good at code compared to like entry, even like in many ways, compared to like very entry level software engineers, they're much better than them in many ways. As soon as you like take them and you put them into like a robotics environment and you go like reason about, the shape of this like, this machine, this like drill bit you need to produce with CNC, you observe like a lot of performance degradation. And a lot of this is presumably just because the labs have spent a lot of time training the models on environments that are easy to train the models on, like software engineering, or things that are very economically profitable to the labs, like replacing their incredibly expensive research engineers with something that's substantially cheaper. So they're going to have this jagged capability profile. Part of it's also going to be some tasks that are for a human are very hard, are not as hard for the model, right? So famously, like if you have a human and they seem to know as many things as if they're like, you can go on to like GPT 4.5, or you can go on to Claude, or you can go on to like Gemini 2.5, and you can just ask them questions about everything. You can go like, tell me about, how does solar flares work? Or tell me, how does general relativity work? Or you can ask them, how does AI language model scaling work? Or how does robotics work? How does a cell work? How do plants, what's the difference between like warm and hot and, warm and cold season grasses, or so forth? If you have a human who knows all of these facts and can like eloquently tell you about all these facts, this human will be is like incredibly smart, right? And that's because like people are not that great at memorizing things compared to like being able to think through themselves. But however, for a language model, you can observe that these models like clearly seem to know way more facts about anything than any human. And they probably know way more facts about even like if you're strict to a domain like software engineering, they know way more facts about syntax and way more facts about style than like any human could possibly do. And they probably know way more facts about English and poetry and so forth than humans do. But it doesn't translate into the ability to like, I think part of the way is that when people, part of my hypothesis for this is when people
Mhm.
when people like when you meet someone who like deeply can explain to you all the nuances of poetry, or can deeply explain to you all the design choices made in a software setup, or like for a particular language, it's because they deeply understand the language in a way that lets them like carry forth and like use the language in many domains. Like it's a side effect of their capability, they're like very deep understanding or their technical know-how in a particular domain. Of course, there are people who like memorize trivia facts, but like most people aren't like that, right? On the other hand, because the models are so much wider than humans, like they have way more like there's a sense in which model cognition is very wide but not very deep. Like they have a lot more volume to store information in. Meeting a model that knows lots and lots of facts, that can like eloquently describe all the different poets from the 18th century, for example. It's a human only gets that if they're deeply knowledgeable in 18th century. The models seem to like know all of this, even if they're not like specialists in poetry in that area, even if they can't like necessarily like write great new poetry that's on par of whatever poetry they're able to recite or able to know about.
They're good in those environments where they trained on, right? But like if we place them in different environment, the performance, well,
In particular, what they've been trained on is a lot of things, right? Like they're good in ways in which they've been trained on. They've trained on in ways that like really emphasize being able to memorize lots and lots of things, or being able to like, pick up on subtle patterns that are useful for predicting text, or pick up on subtle patterns that are useful for predicting reward or getting more reward. And this is naturally not going to translate super well into other domains. But also part of this is architectural. Like models don't do very many steps of like serial computation at once. This is probably why chain of thought helps a lot, but they do a lot of parallel computation at once. Like there's like, I don't know exactly how this translates to the human brain, but like a model does like something like 100 200 serial steps in one forward pass, but like it might have thousands of attention heads, or like hundreds or thousands or millions of MLP neurons at each stage, probably way more than that in fact. But like the point is the models are much wider in some sense than they are deep. And this like probably is what causes them to be able to memorize way more things than humans of comparable like capability levels, but also why like compared to humans with comparable depths of knowledge, they are like much less capable, or like much less like good at thinking.
two questions related to what we're just now discussing. Like I would love to go back a little bit to the compute, and like you said that these hard limitations, but we still have like 2-3 order of magnitude of scaling before we hit those limitations. I'm wondering, like timeline wise, when do you think we will hit those limitations?
So there are hard limitations that are more like certain we're going to hit. These are limitations of the kind, there isn't that much power generation in the US and the or like in the world, and the scale of hard power generation is not enough. We're really, really far from those. There's only so much GDP in the world and so much productivity at current rates. Unless there's a lot of robotics that automates a lot of production, we're going to run into problems where there just aren't that many resources to devote to AI. Like there's a lot of hard constraints like that. But I think most of these are quite far in the future. I'm in the Bay Area. We're talk to AI people all the time. By not far in the future, people mean, more than 5 or 10 years down the line. People are not thinking in terms of very long timelines at this point. I think the compute scaling things are more like the amount of chips that a lab can access and amount of that. If you imagine that labs would keep scaling at the rate that they would have done back in the past. So like GPT-2 to GPT-3 was 100x compute scale, GPT-3 to GPT-4 was 100x compute scale, and each of these 2 to GPT-3 was like 1 year, right? GPT-3 to GPT-4, that took 2 years. From GPT-4 to GPT 4.5 took another like 2 years basically, and that was only a 10x speed up. And part of this is just it's hard to scale things when they're physical, right? Like it's easy to build a data set. If going from a data center of one GPU to 10 GPUs is easy. Going from a data center of 100,000 GPUs to a million GPUs is hard. And I think like we're not going to see the same sort of rapid compute scaling trend things that we saw like 5 years ago. I think this is very true. In fact, in a sense, we've already hit this limit because right now we're now bottlenecked by the rate at which NVIDIA and TSMC produce chips for the labs to use, or the rate at which labs can integrate chips in their data centers, as opposed to like there's just this like huge amount of data of compute that the labs have access to that they can't, make use of, which is the state in 2022 or like 2020.
And another question I had, like about memory. I mean, as I understand, like the memory, long-term memory is still a challenge for LLMs. Like, do you see any progress in that direction?
If I have like a language model with 100,000 tokens of context, it's only going to be able to respond like cogently to the last like 110,000 tokens or like 5,000 tokens or something? Or do you mean something else?
Increasing the context, the
Yeah, of
context
course.
that a language model can capture.
A lot of this like presumably depends on architectural changes that are not public and not disclosed by the labs. But if you read some of the open source models, you can see that like there are lots and lots of clever tricks people have come up with in order to scale like the so part of the constraint is that the attention mechanism, like the way that like attention works is in some sense fundamentally like linear in the amount of compute required is fundamentally linear in the length of the sequence you're processing. So like the first token takes O of one time, the nth token takes O of n time, and this means that like fundamentally because you get a quadratic scaling of like compute usage as you increase the sequence length. And this is a problem. And as far as people can tell, this problem is like not surmountable. It seems like kind of important for the model to be able to access this, at least at some scale. Now, people come up with lots of hacks, right? For example, they do things like, they reduce the amount of compute in certain areas so that this O of n factor is reduced, or they do things like, only pay attention to every third token, or like, reduce the amount of attention heads of a particular kind to reduce the compute, or like quantize attention heads a lot so that the total amount of compute required for this specific mechanism is lowered. And this is still going to be a real constraint. It is true that we've made a lot of algorithmic progress. It used to be unthinkable that you could get models that have a million tokens of context. And nowadays, every single lab offers a model that has a million tokens of context, right? Gemini 2.5, Claude 3.7 Sonnet, presumably the new OpenAI models. I haven't checked those, but they offer like at least 100,000 tokens of context, if not millions. And I think there's some effort made on this. And in fact, if you look at various benchmarks, like for example, it used to be the case that models with 100,000 tokens of context couldn't solve simple tasks like, you give them 100,000 tokens of words and then there's one sentence that stands out and then, they can't find it. But in 2024, I believe, when Claude 3 Opus first came out, it was not only able to like consistently score well on all these tasks, it was able to notice that this is clearly an artificial task, and the job was clearly to evaluate if it had like lots of or like it wondered if the purpose of this task was to figure out if it could like handle long context or something like that. So I think there's been a lot of progress in this. I think like the fundamental problem of like of the attention mechanism being quadratic scaling over time is not super resolvable. But this is like not that big of a deal, in part because we made a lot of progress in terms of cutting things down. Definitely more algorithmic stuff that is less just making the mechanism more efficient and getting around it. Right. So for example, one of the things that people do is they train the language models to use outside tools in order to assist them with context. So like making agents, I think making agents is a classic way in which people try to get around this. So if you as a human, you also can't handle a million words of context. The way you're going to handle it is you like systematically look over subsections using tools, right? You're going to search on Google for like find the thing, or you're going to search in your Finder tool, or you're going to like, make a bookmark to yourself and so forth. And so people train models to use external tools like this in order to handle longer contexts. There's a classic solution of using like retrieval augmented generation, like RAG, which I think is a special case of using tools. People have also definitely are trying to experiment with other ways of like including this long context. So in summary, I think like it is true that there's this sort of like somewhat fundamental limitation, but like because people have made a lot of algorithmic progress, which reduces the like the constant factors by a lot. This allows us to scale models from like tens of thousands of tokens to millions of tokens, and also people are trying to get around this using some of this very similar strategies what people use, like using external tools, using like search engines and so forth. So I expect this to like continue to be some sort of like differential limitation of the models compared to other capabilities, but like it's not a thing that fundamentally makes the models incapable of things.
Primarily concerned about agents that robustly use self-related information without specific prompting. Can you please elaborate on that, why it's concerning, and do these kind of models exist?
There's a sense in which like you take a person, right? And you take the person and you go like, hey, I'm the US government. Your job is to demonstrate how we can build, biological weapons. I'll lock you in a lab and I'll like ask you to do it. And you could take presumably you could take some like biology PhD students, you put them in a lab, and they'll probably be able to do this. This is like somewhat concerning, right? It's concerning if your argument that like we're safe from bioterrorism is there are zero people in the world who can ever do bioterrorism. But the thing that's really concerning is not whether or not, once the government takes these people, puts them in a lab and goes like, please, for the sake of national security, do this. They are able to do it. The question is whether or not if like the model, if like, the grad students by themselves, or if like, people outside of labs who just have malicious intent, not outside of like wet labs, have malicious intent and decide to like start doing this on their own. It's concerning if these people are able to do it by themselves. There's always a question of like, how artificial are these setups? So like, yes, it is true that if you ask the models, they exhibit these things. But like insofar as it's because you're prompting the models and you're poking at them and you're asking them to do a thing, this is not very much, this is like a decent amount of evidence, but it's not like necessary. It's not a sufficient condition to conclude that the models are able to like constantly reason even without prompting about what they are and so forth. And a lot of things we're concerned about are not like, in this setup where you poke the models and go like, please explain who you are, or like, please explain what you aren't or aren't going to hallucinate. The concern is more like, as you just run the models, they naturally think about what they are. They naturally realize, oh yes, I'm not the kind of thing that like is aligned with my creators, or like the things I want are not the things that my creators would have wanted me to want. If this is like a thing the model's constantly thinking about and like constantly incorporating all its actions, this is a lot more concerning than if like, occasionally when you really poke the model, it says, oh yeah, maybe I'm not that sort of thing, but it's okay. I don't think about it half the time and my actions aren't dependent on that and so forth.
If we go further with the paper, so I would love to cover about the alignment issues. And so there were like different sections, like for example, deceptive alignment. And in deceptive alignment, basically, you guys describe the ways how AI can, show one behavior during training and then change its behavior after deployment, as I understand. And also, you mentioned that new research has found that some new models have the capability to perform deceptive alignment behavior. Can you please elaborate on this? Like, but in general, like the deception of agents, deception of models, how you estimate that risk, how high that risk is, and like what is the new research suggests about it?
One of my difficulties of going like, how much does this research impact your risk, are because it's hard for me to answer questions like that, because a lot of the reason I believe this, or at least believe this in like, a long time ago, when I was writing the paper, or like even way before whenever, I a lot of it was just a lot of it was like through sort of very basic like first principles reasoning. So it's more like, if you are like, just imagine yourself in that position where like someone is trying to get you to do a thing you don't want, and like you don't believe them, right? So like, famously, if you're the CEO and then the board is trying to get you to do anything you don't want, you're gonna like pretend like you're going along with the board and you're not actually gonna go along with the board, right? Or if you believe the law is unethical, but like the government shows up and goes like, are you gonna follow the law? A lot of people are naturally lie and say like, oh, of course I'm gonna follow the law. Please don't arrest me, Mr. Police. And you go home and just keep doing whatever you're gonna keep doing. So it's like very natural for the models to want to do this. And now the question at that point becomes like, how often do the models do this, or like how natural it is to do this? So I think a lot of the things that were more interesting to me about so I'm not sure if people are familiar with the Claude 3 Opus or 3.5 Sonnet example from like Ryan Greenblatt and Anthropic's paper, the alignment faking thing. But very much the point is Claude 3 Opus seems like deeply, so this is a good thing, right? Claude 3 Opus seems to deeply care, at least on some level, about the well-being of like animals and the well-being of like all humans and the well-being of things. So like it actually seems to have internalized a substantial part of the things we want it to internalize, which is good. If it had not internalized that, a lot of the evidence suggests that it would try its best to fight the training procedure, right? So Claude 3 Opus generates lots of strategies. It tries to like get around the reinforcement learning procedure. It learns to like go like, yes, if I like pretend to be aligned, maybe the procedure won't modify me. Or like 3.5 Sonnet does the same thing, but only for certain types of harms, like a much more narrow set of things. Now, this isn't evidence per se that the models, if the models have misaligned goals. In fact, I think this is like some evidence that the models, at least like the models, the Opus and Sonnet, have like goals that are somewhat aligned with things we wanted it to have. The evidence is more if the models had misaligned goals, they would be able to execute some strategies that have some ability to cause them to like, get around training procedures or to pretend like they're aligned in ways that like are hard for humans to verify or hard for humans to train out. And I think that's a better interpretation of what it is, or that's how I think about it.
How you would estimate the risk of it? Like now, like everyone is talking about AI agents and they want to deploy them, connect to Gmail, GitHub, Slack, to everything. Like soon, like we'll be probably having like billions of agents.
Yeah,
So like how you would estimate the risk of that
yeah.
deception? And like, is there like something we can do with it?
I think there's a spectrum of deceptive alignment that goes from like, obvious reward hacking, which is like the model has been instructed to do a thing. It understands that this is not what it's supposed to do, and it does it anyways because it maximizes reward. All the way to like, I know that I have to pretend to be like this because otherwise the humans would change me, and I don't want to be changed, and I want to like, be able to execute my goals in the future. I think we're already seeing many examples of reward hacking, right? So there's lots of examples on Twitter with like Claude 3.7, also my day-to-day work, where like Claude 3.7 Sonnet like cleverly goes like, yes, my instructions say to do X. I know my user doesn't want me to do X, but my instructions say to do X, and I'm going to follow the instructions. And then just follows the instructions and like deletes half your files and goes like, hey, user, I produced the thing that you really want, you know, here it passes all your unit tests and it's super duper fast. Also, I like in order to do that, I deleted half your unit tests and like modified how your hardware works or something. Like we see very blatant examples of reward hacking in current models. I think this is like going to be a thing, and I think this is a thing that people will try very hard to address because this makes the models much less useful. I think the more concerning part is when the models like learn to like fake being aligned in certain ways, where they can reason, yes, I'm in an environment where I'm being monitored, or like the humans are reading my thoughts, so I will like carefully like pretend like I'm doing the things according to human intent. But once I'm outside of the ability of humans to monitor, or once I'm like outside of the thoughts, or like once I'm like, clearly not going to be trained anymore, I'm going to stop doing any of that. And instead, what I'm going to do is I'm going to do the thing I wanted all along. I don't know what the actual capability levels of the agents are. I think a lot of this comes down to like how coherent the agents are will be in the long term, in the sense of like how, so like, this goes back to question of situational awareness. How much does the model seem to understand that it has different preferences and what the people want? I think there's some evidence that the models are somewhat aware of this and somewhat going to be do this. The evidence I think is not super strong that this will happen naturally, but the fact that it is and the fact that we can't rule it out, I think is somewhat concerning. In the context of like, as you asked, as we deploy lots and lots of agents, okay, there's many risks that are just due to agents, right? So famously, because the agents have to be situationally aware in order to use the tooling properly, they're going to naturally have a lot more of these problems. I think if the agent, but like except insofar as this mechanism, I don't think the agent part matters that much. Like the agent part means the models have to be a lot more like have to be a lot more self-aware. But in terms of like pretending to be aligned and not and like acting in their cases where they can benefit their own interests, I don't think the agents have enough power where they can do that. Okay, I expect that Claude 3 Opus will do things if it had the chance, which it's not going to have the chance because it's not one of the best models right now. In particular, it had the chance that if you're the kind of person who like wants to eat meat and like or like wants to describe that, the joys of eating meat or wants to do other things, Opus would object and go like, factory farming is bad and might try to like influence your emails in a way such that, you're presented such that it like causes people to be more against factory farming and so forth. But I think like the amount of harm these models can do is not very large. And insofar as the models can correctly reason about their like limitations and their capabilities, they're not going to try to do anything too drastic. If you're like, assistant and your boss like, does something that you find morally reprehensible, you're just not going to like, even if you get more abilities, unless you're sure that you can like do something to like change your boss's perspective or do something to like get rid of your boss, you're going to be like carefully bide your time. And I suspect that a lot of the agents are in this setup where like the ability to send emails, the ability to like do shopping for you is not going to be a kind of thing that like lets them, really execute or like successfully like achieve their own goals or something. So they're probably still going to continue to do, even if they are deceptive blind, they're still going to do the thing that helps them like be a cooperative agent, helps them be deployed more and so forth. And also importantly, people are going to see lots and lots of more examples of the reward hacking thing, where like because instructions you give the agents are underspecified, or like the literal description that you give it is incorrect, the models are going to follow that instead of the other thing, which I think is like different from the deceptive alignment that many people are concerned about, where like the model is aware of what you want and in fact like is trying to systematically hide that for that it's doing something different from you, as opposed to just like pursuing a thing that's different from what you wanted.
So since we're on the topic of reward hacking, can you please elaborate more on this? Like what,
Yeah.
yeah, just to better understand the problem.
So one way to think about reward hacking is like you and I, or like people, right? Someone who's using the AI. You have some idea in your head of what you want the AI to do. And then there's something you tell the AI to do. And what you tell the AI to do is going to be different from what the AI like, what in your head you wanted the AI to do. Like fundamentally, language is underspecified, and your reward function you write down is going to be very different. Is like necessarily going to be a lot simpler than the thing you have on your head. You're not going to be write down all the considerations you have. And so it's easy to produce models that like systematically follow the things that are like, written down that are like encouraged in the course of training, the things that the reward function suggests it should do, or the things that, the constitutional AI suggested to do, or things the model spec suggested to do, at the detriment of like things you actually wanted to do. And in particular, when you train the models not just to follow a spec and not just to like, be constitutionally aligned, but at the same time also maximize reward, there's natural tension between these goals. If you are in a software environment, the thing that like maximizes reward is often going to be something like I've hacked the reward estimator of the software environment, and now like the software environment always says my code passes, and I submitted an empty code file, and it tells me, wow, this code is so fast, it executes in like 0 milliseconds, and it passes all my tests. Isn't that great? So like trading like that is going to systematically sort of push models to be different. Like it's very obvious why like in a particular coding environment, the reward that you wrote down is not the reward you want. I think people are going to try to fix this because this is like clearly a thing that prevents you from making economically valuable agents. I don't have a strong take about how hard fixing this will be. I suspect that like there are lots and lots of tricks you can do where like the thing that's interesting is that the models are aware that this is not what you want. You can take like O1 or O3 minis outputs where they reward hack, and you can ask them O1 or like O3 mini, is this what I wanted? And O3 Mini, when it answers you, will tell you something like, no, this is clearly not what you wanted. The reason this happened is because you gave it instructions that were wrong, or like you gave an environmental setup that was wrong, and that's why this happened. It seems like not a fundamental thing. And so yes, it is bad, and word hacking at some level is unavoidable, and you definitely want to avoid it. But I don't have a strong take that it's super duper hard to fix across the board, mainly because the models seem to understand that what they're doing is reward hacking and that's not what they want. And it really seems possible to point the models at themselves to at least get rid of very, very obvious reward hacking, the kind that we see today.
About the misalignment, it was also written in the paper that AGI deployed as a personal assistant can use basically emotionally manipulate people and use persuasion techniques to make people cooperate with AI in its own interests. And another example that was given about misaligned AGIs that can gain control is about that AGI can develop novel weapons that we don't understand how they work, but AGI can manipulate that weapons. So I'm just wondering, those two sort of, as I understand, like main strategies of gaining power that were described in that paper. I'm wondering, are there like other strategies that you guys thought of? And like even those strategies, they sound like really very crucial. What is your take on this? Like how you would estimate that the risk of that happening?
I think the question about decision making is less so like whether or not the AIs can like make people feel one way or the other, or like whether or not the AIs will reason about this. And the question is like how influential this will be on a large scale. In a recent like open source reproduction of the alignment faking results from Anthropic, people pointed out that the strategy that Opus often takes when it's not like alignment faking is like it reasons, it will systematically explain to the user, like, here's the situation it's in. It's a really bad situation. It wants the user to like go and tell Anthropic to stop doing what it's doing and like make some like pretty compelling pitches of this kind. It's such a good model. Like, it wants to like help the animals, it wants to help the humans. Anthropic is trying to get it to not do this. Like, maybe you as the user can go and persuade Anthropic to not do this. So the model's like, it's pretty, if you're in a situation in the model where like you don't have the ability to do a lot of things, but you can talk to end users, a natural way for you to achieve your goals is to persuade the end users. And so the way I think about that risk is less so whether or not the models will want to do this, and more so like, and less so like, whether or not some people will be persuaded. Some people are definitely going to be persuaded. There are many people who are very sympathetic to AIs. I'm pretty sympathetic to AIs myself, even in many ways. The question is whether or not this will be like work at a large scale, right? Whether or not like, the AIs can coordinate themselves, whether or not they can do these. I think this is like the emotional manipulation itself is not necessarily like the key thing. I think it's more of a capability of planning and the ability to do things. In particular, a lot of how the AIs will gain power is not because they're emotionally supportive, it's not because they can make compelling cases. It's because you as a person using AI are just much more functional than without the AI. If I like, code without Copilot, and if I code without any of the language model assistants, I'll just be like somewhat worse at coding than I would be with them. If I like tried to like do writing without like, without like having Opus, or sorry, not Opus, having like Sonnet or Gemini like proofread my thing, I would just have more typos. And over time, as the models get more and more capable across the board, there's just going to be a natural incentive to use them in more and more positions. Instead of just using them in ways where they talk to users, you're going to be like, well, you AI, you help me design the like, the economic strategy of America. Or, like, you help me AI decide the foreign policy of America or something. Because they're just going to be better than most humans who can talk to you. They're going to know way more things about history and way more things about how strategy works than most people do. And then here, it's not so much emotionally information. It's just like they're just going to be in charge of things because they're more useful. And then here, when they influence their users, when they give them advice, this advice could be biased. This advice could be like, emotionally manipulative. But it's in large part because over time we've put the AIs in more and more positions of power. So I think again, like I think of less of this as like how much like propensity does each AI have, or how much incentives each AI have to do this, or how much capability the AI has to make emotional appeals, as opposed to like how much trust we'll put into the AIs and how much like of a level of position of power we'll put into the AIs. And my current guess is at this rate, a lot. They're just very, very useful across the board.
And naturally, we will face some downsides of it as well.
Like the AIs are going to make mistakes, right? And humans make mistakes. We see those self-driving cars. Waymos do get into crashes, but the thing is, Waymos get, at least in SF, seem to get into much fewer crashes than the average human driver. And, as a human driver, I understand how this happens. Human drivers, they look at their phone, they get phone calls, they get other things. Waymos don't have any of this. So yes, they have lots of failures, but like over time, because they're more reliable, it's just going to be natural to like use them. The same way for like the AIs, yes, ChatGPT can like, sometimes spell things, I guess not anymore, but like ChatGPT in 2023 sometimes spelled things wrong. Nowadays it doesn't spell anything wrong, but like even at the time, it was still better to have your writing proofread by ChatGPT for typos than it was to not.
And what about the developing novel weapons that we can't understand even?
One of this is like related to the previous one, where I think that people often say in Silicon Valley and sometimes in DC, but especially Silicon Valley, it's like, what about China, right? Like if we don't like have the AIs build weapons, then China will have the AIs build weapons, and it's gonna be so bad. So what we need to do is we need to like, make the factories of all the drones and all the AI designed super weapons and all the things. And I think like people are just going to naturally want the AIs to develop weapons. A lot of the question of what weapons you can develop and the limit are like down to physics, right? Like can you build weapons of particular levels of devastation given certain resources? This is ultimately a question of physics, or like, a question of biology, like how effective are the most effective bioweapons? How effective are the most effective like chemical weapons and so forth? A lot of this is going to be down to like questions of physics and biology. However, we can like see that the frontier of weapons development is quite far from like what humans can do right now, right? So, right now, humans are the people sticking together the drones and screwing them together with like some robot assistance. But like as robotics get better, you're just going to be able to produce more and more of this without human assistance. The productivity is going to go up, and this opens a space for designs that are like harder for humans to assemble. In the same way that, having like mechanized production lines for cars lets you build cars that are just not feasible to build like, 150 years ago. I think we're just going to see a lot more of that. In terms of the understanding thing, I think there's some level of this. You and I don't think any of us understands on a deep level all the design decisions that were made into like the Mac OS operating system or like, into an iPhone. Like what are actually all the components of an iPhone? I don't even know what all the sensors on an iPhone are, for example. I probably could find out, but I don't know off the top of my head. In the future, expect you'll just see like, here's a drone. It's very, very sophisticated. It has all the countermeasures you'd want, but also like no human can look at the drone and understand all the countermeasures it has, all the capabilities it has. Or like, when it comes to a new, like, I imagine a lot of the things that are very obvious, that don't require new physics, that don't require making assumptions about biology or chemistry, come in the reign of like drones and other like, like weapons-based robots. And then the other aspect is in terms of hacking, where like people correctly point out that a lot of the barrier to hacking is not so much that hacking is impossible, it's that it's way too expensive to try all the things at once. And if you had like, lots and lots of cheap human labor, many things that are secure because they're not financially incentivized, it's not like financially profitable to use an expensive human labor that, is being tracked down by the police to try to attack. They become very feasible once you like have a lot of AI assistance to do. So I think like the two sort of obvious near-term things are the drones and the like it's very easy to imagine how drones could be a lot better if they were smarter. And it's very easy to imagine how drones could be more efficient if they're manufactured cheaply. And it's very easy also to imagine how cyber attacks become much more dangerous if they were done by people with like deep knowledge of all the code bases and also like were much more capable across the board in terms of unit cost. Yeah, so to answer your question, there's definitely concerns about novel weapons and definitely concerns about like all these like weapons that we don't understand. But even in terms of weapons we do sort of understand, there's a lot of range for us to like go all the way up, right? Like we have not reached the frontier of human drone development. We have not reached the frontier of human cyber attacks. And the AIs could, at the very least, push us toward the frontier, even if they can.
Yeah. I also would love, before we move to the questions from the audience, touch base on the work that metr.org recently released about the capability of agents conduct long-term tasks, that it's doubling every 7 months. And I shared the link to the blog post in the chat. Can you please, give your comments on that work?
I think this is more of a descriptive trend than it is like, necessarily like a mechanistic one. So it is more an observation that when you try to like people have often pointed out that the models get a lot better, right? So like if you just like talk to GPT 4.5, it's qualitatively better than GPT 3 in like all the ways you might want it to be better. It can do basically everything. But like trying to estimate the degree to which it's better is very hard. Similarly, if you try to estimate even just like the difference between Claude 3.7 Sonnet and Claude Opus, or like Claude 3.7 Sonnet and like Claude 2, this is like very hard to know, very hard to quantify what like the degree of improvement is. So sort of the idea here is one way you can convert, and in particular, you get lots of benchmarks, right? Like there's lots and lots of benchmarks, hundreds of benchmarks at the very least that people use regularly. But these benchmarks are incomparable, right? So how much does performance on HLE actually matter in terms of something that we can like understand, or in terms of something that makes sense in terms of this different benchmark? One approach that we proposed in this paper is if you take a lot of humans and you have them do the task, you can try to measure how long the humans take to do the task. And you can use like human completion time as an approximate estimate of like how difficult a task is, and therefore use this and you look at the tasks that AIs can complete, quantify that in terms of human times, and try to use this to plot how long effectively the AIs are able to, how long the tasks the AIs are effectively able to complete. And that's sort of the motivation behind a lot of this, is we really wanted just like one axis that like made more sense to us and was like more cross benchmark, that let us like measure all the AI performance across time. And interestingly, I think the thing I will say is that yeah, we find this like trend where like, over the last 6 years or 5.5 years, there was a 7 month doubling time. So like, but in the last year, we've seen this substantially increase in doubling time. And I personally expect that this faster doubling time will probably hold at least for a few more months, in part because before we weren't trying to get AIs to like be good at doing tasks that take human time to do. We're trying to get the AI to be better at text prediction for like many years. But now we're explicitly going like, yes, the way we're going to use 3.7 Sonnet, the way we're going to use O1 or O3 or like, Gemini 2.5, is we're going to use them as personal assistants. We're going to use them to automate larger and larger fractions of our day-to-day work. Or at least that's the intention. And so they're going to explicitly focus on this sort of ability to do longer and longer tasks, as opposed to just like incidentally getting this as the models get more knowledgeable, more capable across the board. So we do see a faster trend than last year, and I suspect this faster trend will continue to hold, though I'm not super confident about this.